It was interesting last night. I went out with some folks from your group, and I was sitting there listening, and it could have been a meteorologist conference. Let me tell you, it was, the talk was very much about weather, and I was thinking, this is exactly if there were 5 or 6 meteorologists sitting around the table, the exact conversation. So you all look at very similar things than I do. So much of what I'm going to show you, I know there is the information that you look at and are very interested with. But I wanted to talk about the drought to start with, and this is a progression of a drought, and where Evelyn might go back 1,000 years, or I'm not sure how far you go back. I tend to go back not quite as much on recorded data that we have. And as you all know, drought is a normal occurrence. We do go through periods of drought. This is over the US, but the drought we've gone through more recently, from my perspective, is somewhat unique for a number of reasons. And very simply put, it was extremely hot and extremely dry. That sounds fairly simple. But I think oftentimes when you're dealing with drought, they can occur in a number of ways. I've learned with weather, it's very humbling. Just when you think you know everything about it and you make a forecast, and I've been a forecaster for a very long number of years, things can really humble you. But usually a drought, in my experience, will start with one of those variables, temperature or precipitation, an anomaly in one of those. So you might end up with rainfall being less, and then that'll impact temperature, or temperatures being warmer than usual, and that'll impact rain or water resources. And then they get in phase, and you get into your drought. Well, I think really the drought we went to last summer over most of the Great Plains was somewhat unique in that both those variables, those anomalies, the intensity of the anomalies was incredible, but also that they both came on very similar type of time frame and intensity. So when I say it was very hot and very dry, it was, but I think what was unusual is how fast it both came on. And Evelyn used the word flash drought, and that's what I use as well. It really was a flash drought. Most droughts typically evolve. This one just sort of erupted. Now, if we look at Oklahoma here, going back, you can also see the intensity, and you're all probably familiar with the Drought Monitor. And to have a D0, D1 drought, a minor drought, that's nothing unusual. But when you get into the more extreme or exceptional drought, that's when you really get into your different, more severe impacts. And you can sort of put in perspective over a fairly short time frame here from 2000 how severe these droughts were. The darker reds are the more intense drought. And they really, really hit the area as well as the Great Plains. Now, one of the things as a hydrometeorologist, I look at this right here, look at this gap. The first thing I ask is, did we have 2 separate droughts, or was that just one prolonged drought with a break in it? And you'll probably hear me say this a number of times, but you have to think of your overall climatology and water replenishment. Is it masking a drought? It's not ending it. So sometimes you think a drought is over and improving, and actually what you're seeing is an actual progression of rainfall that's masking it as you go through a recharge season, such as winter, only to have it come back and come back strong again. Sort of like if you have a big fire and you're putting some water on it. If you don't extinguish that totally and start to reverse it, it very well could come back again. So when I see a graph like that, pretty much I think what was driving this first section right here was never totally extinguished, and it came right back again. Now, over the last year or so, the other area of drought was over the southeast US, and I've given a lot of talks on drought, and they were very different. The southeast US drought in some ways was quite puzzling why it didn't go away. It was much more isolated. It was much more of a micro-scale drought. The Great Plains drought is a much larger drought. It covered a lot more area, and I think you can describe it a little bit clearer than the southeast drought. And there have been changes, very significant changes over the winter months as well. Okay, so if we go back here looking at, I just picked Oklahoma City. This is an accumulated precipitation running total. It gives you a little bit of insight of what's been going on. If we look at, it starts at 0 1 year ago. We had a little bit of improvement. And then ever since then, since summertime, you can see we've we consistently have run a deficit of precipitation. It really hasn't caught up too much. Now, if I start that same image in winter, what you see here is towards the end, we have had some recent improvement. I'm going to talk about the snow probably in just a bit here, but there has been, over the western part of the state, somewhat of a significant snow. Matter of fact, from a national perspective, it's very important, these snow bands, where the snow is occurring, and the northwest Texas, western Oklahoma, parts of Kansas, Missouri, that snow band is actually one of 3 primary snow bands across the nation this year. And that's very important because a lot of times wherever these snow bands develop, subsequent tracks of lows will follow along that. So it developed sort of late in the season. It would have been nice if it would have developed maybe a little bit earlier, but that was actually something significant for the winter months. And I think I'll talk about that in a little bit more. So we said about a flash drought, and here's one way to look at that. Early June, we were prone towards a drought. We were droughty. But look, as we got into September, how it just exploded. I'm not going to say that's unprecedented, because in weather, you can almost find an example of anything happening. But I think it was unusual. I also want to reinforce what Evelyn said on the role of soil moisture. Soil moisture is incredibly important, and I'm preaching to the crowd here. You deal with this every day. But soil moisture is tremendously important for many, many reasons. I could go on and on. It's important for runoff into reservoirs, but from an agricultural perspective, until you not only have some recharge of lower soils, that's really when you start to get your improvement of drought. We see many areas of the country right now where upper soil moisture is in fairly decent shape. It's been recharged to some degree, but that happens every winter. There are reservoirs in the middle of a drought that will recharge every winter. Soil moisture will recharge to some degree over most areas every winter. The problem is there are short-term and long-term impacts, and if you don't address the longer-term ones, such as the lower soil moisture, what's going to happen? The minute it warms up, it's going to percolate down, and then you're going to end up drying out those upper soils faster than normal. You're not going to have as much moisture getting into the atmosphere. You're not going to get cumulus clouds. You're not going to get thunderstorm and afternoon convection. So it's not just the upper soil, it's the whole column of soil, and that's what's important. Okay, but having said that, sort of looking at temperatures from a global perspective, looking at the trend line of temperatures, these are summers, and you can see that there's definitely a longer-term trend going on. The green is a trend line. Summertime temperatures from a national perspective are definitely warming up. You don't see it so much with precipitation. Precipitation is not going up as much, but definitely summertime temperatures are definitely warming. Let's take a look at Texas and Oklahoma for the last 30 days, what kind of trends we can pick out here. And what we have here, you can see blues are above normal. Here's the scale. So blue would be about 2 times normal, the precipitation, and red would be 25% or less of normal precipitation. There's that snow track. Sort of interesting how that developed. It developed right in this area, extended up into the western part of Missouri, parts of Iowa. Snow is actually more efficient in some ways than rain in water resource replenishment. Now think about it in wintertime. If it rains, because your evapotranspiration is either reduced or zero, that water is going to tend to soak in, but if it's in the form of snow, it's going to soak in at a more manageable level. You're going to want it to sort of gradually soak in. Oftentimes you get runoff. If you have an impervious surface, it'll run off, and even if you have snow, you would have that. But if you have snow on the ground, it's more likely to melt off in bits and spurts. So snow is good if you're looking at drought. Now, if we go back to the 90-day, we don't see the trend quite as much, but I think in blue you can still see it. There's still a trend there from north Texas up to Oklahoma of above normal. And then if we go back further, a lot of times on these precipitation data sets, the smaller scale trends will tend to wash out or average out over time. So when we're looking at a 30-day, you're seeing more of what I would call a mesoscale or microscale type pattern. If we get more towards the 3 months, 6 months, up to a year, you're getting the broader picture. So then we get into the broader picture. This is 180 days. You still see a hint of it in North Texas, far west Oklahoma, but the rest is yellow, which is below normal. And that's sort of the story. For the short term, there's been some limited improvement over some areas, but the long-term story is still below normal precipitation. The U.S. Drought Monitor, we're starting to erode the drought in spots. And again, I got to be careful to not present that this is eliminating the drought. This is normal. So the question is not so much the wintertime rains, whether it's going to eliminate the drought. Right now it is helping, it's starting to bring it down, but we're going to need more. We're going to need reinforcement. This is not enough to put it out. So how do you end a drought? One way. Well, there's many ways you can end a drought. I know over the southeast U.S. they always say a hurricane will end a drought. Well, I guess it will, but that's not really the way you want to go. You want a manageable way to end a drought. I also point out that to end a drought, I think it's more important to get normal precipitation over a period of time than to get abnormally high precipitation over a short period of time. I think the prevailing wisdom is to end a drought, you need a historic rain event, and that'll take care of it. Well, I guess it would, but those type of rare events are rare. It's more likely that what we want to do is get in a pattern of more normal rainfall over a sustained period of time. That is what we really need to get us out of the drought here. Okay, so how much rain does it take to get us out of a drought? I think that's a very simple way to look at it, but it's also an easy way to look at it. You can see that there has been some improvement. At one time in Oklahoma, we needed 6 to 12 inches of rain, and now it's closer to 3 inches or 4 inches. And that's why I say keep your focus on if only we would get normal rain month after month after month. I think that's the way to look at to see improvements rather than, hey, we need a 6-inch rain. No, I think it's more just normal rain over a period of time. The other problem with that 6-inch rain, if it comes too quick, more of it's going to run off. It's not going to be effective at recharge. Okay, now, in my newsletter I put out, I try to take a snapshot of water resources, and it usually looks like this. And one of the things I try to do is I try to understand what is causing what's shaping our weather patterns right now. One of the teleconnections, and a teleconnection, simply put, is an observation of a sea surface temperature or an atmospheric temperature that fluctuates from one realm to another, from positive to negative, say. And it has been noticed that when this occurs, there's an impact to weather somewhere. So for example, with an ENSO, that is an anomaly of a sea surface temperature in the Pacific in a certain region that somehow impacts the weather somewhere else. And over the years, we've looked at these. El Nino is a longer-term one, medium to longer-term one. Evelyn's talked about the real long-term ones. The one that I focus a lot on in winter is the Arctic Oscillation. And basically, that is looking at pressure differences between high and low latitudes. It's simply put, what it's doing is it's saying the cold air that can be locked up by the Arctic jet stream, is it relaxing and letting it sag south, or is it holding it up there? Now, I'm not going to say I'm not interested in temperatures, because I am, because they're linked with water, but I'm a precipitation guy. I'm looking every day at rain and snow. So my interest is what impact does the Arctic Oscillation, or AO, have on U.S. precipitation? And there are clearly defined patterns with the AO that have a fairly good track record on precipitation, primarily in winter. Now, a limiting factor with the Arctic Oscillation is that the computer models only run it out to a couple weeks, and there's not a whole lot of accuracy. So that's one limit, is that when I deal with medium range models They usually a couple weeks is what I'm looking at, because the models just don't work well after that. They're not really long-term climate models. But so far this winter, it's been 90% in a negative AO. Now, what can you say about that? Well, the upper Midwest and the East has been cold. That is very typical with this AO. But there's some real key precipitation trends as well. Keep this in mind. When the Arctic Oscillation is strongly negative, it tightens up the thermal gradient. It tightens up the differences between areas that are warm and cold. That cold air usually sinks down south and then sort of stabilizes, sort of stops. Along that gradient is where you're likely to get repeated patterns of heavy rainfall. And that's what we saw so far this winter. This is just one example. The lines are that gradient of temperature, and the purple is a heavier precipitation. So when I forecast a strong negative phased Arctic Oscillation, I also forecast enhanced precipitation along the southern boundary. Two good examples. The southeast U.S., I forecast drought improvement because of the Arctic Oscillation. You typically get the thermal band over the southeast U.S., and there was significant drought relief over that region over the last month or two. I also looked at, in the cold air side of it, the Texas through Missouri and that region, to have 2 or 3 snowstorms lining up along that, which we've had as well. Notice how compact those snow bands have been. You don't go too far southeast from there and you're out of snow altogether. And that's because it stayed right in that thermal gradient. Okay, finally, the long-term forecast, and keep in mind that the certainty is nowhere close to what you're hearing on your nightly weather report. So here's your forecast. This is a 3-month forecast. Basically, it's continuing the above normal temperatures, and for most of the west and southwest, below normal precipitation. Some of the factors this time of year is the snow cover is going to play a very big role, but I still get back to that point. Has the drought really been eliminated, or has we just seen some improvement? One more here. This is a longer-term model, 3-month precipitation model, and for the 3 months forecast here, it is showing some improvement. Green is an improvement, but then as we get through a 6-month, it's getting back into drought conditions, and that's that scenario that is certainly a realistic scenario, that we could have some improvement over parts of the area for the next month or so, and then we could be going back down into a deficit situation. So your soil moisture percentiles as we get out for the 3 months, yellow are deficits, and I've been looking at these month to month, and there were many, many months that there were just large areas of red on here, which is like really bad soil moisture deficits. Right now, it's sort of shrinking it, and even over the southeast U.S., it's sort of eliminated it. So when I look at this, I could say there's a little bit of sign for modest improvement, and that is what the majority of the models are showing. The outlook overall, though, is persistence. My experience with the Climate Prediction Center is this is what, sometimes what we don't know. When we don't quite understand what's going on, we're going to continue the trend. And I'm not sure if that's a bad scientific approach overall. In the infancy of long-range climate prediction, unless you're sure that you understand what's going to change that outlook, something's definitely driving it now, and we heard a number of things today that would be driving it. Continue with persistence. So I do see that a lot. So sort of some factors I put together here on Oklahoma and Texas is, unless you maintain the magnitude of the extreme events causing the drought, it's going to start to improve. So in other words, only normal rainfall would help significantly. So ENSO would say that being in neutral conditions, generally speaking, normal amounts of rain, that would help. Persistence would be the status quo, stay where we're at. The medium-range teleconnections, if this Arctic Oscillation stays negative, I think there could be some modest or slow improvement. We've seen that in some areas where there's been some snow. Climatology, now this is, depends on what your frame of climatology is, But from a short-term frame, intense droughts, you can say the average length of time. An extreme drought typically lasts, say, 3 to 4 years. After that, you're playing the odds that something's going to come and improve it. Now, they're decade-long droughts. You know, there are exceptions to that, but there are also ones that last just a season. So from climatology, I would say that that drought we've had, you would see some improvement. And finally, climate models are hinting at some modest improvement. All this is very modest. It's not a radical change. And I have to say, over the winter so far, for most of the region, I just have not seen signs of enough of a change to turn this tide. That lower soil moisture is still definitely below normal, and until we can get some recharge, it's going to impact the upper soil moisture as we get into the hotter months. But we have a little bit of time here the next couple months, and I'm hoping that we do see some pattern that does bring us some enhanced rainfall. I don't see it right now, but the models are hinting that there could be a little bit more. Okay, just 1 or 2 minutes, just if you have any interest in what I do, what my job is now, is I put out a variety of reports dealing with precipitation. I put out a monthly newsletter. These are some examples of it. I put out a personal precipitation summary for your ranch. Every month you'd get a summary specifically zoomed into your area of how much rain fell from an aerial perspective. And something I have fun with, and my clients seem to like it. I get a lot of good, favorable comments. I like to talk, I guess, and I put out a weekly video every Sunday, so you have it first thing Monday morning, and that's when I really get into these trends of precipitation. If I see a big trend coming up that's going to impact your operations, I'll be talking about that. Feel free to email me at any time if you have any further questions that are not answered today. And you can, if you are interested in a subscription, you can sign up on my website, or else just let me know. I'd give you a trial subscription too.
John, thank you so much.
Okay, sure.